All right, now we're going to do our algebraic limits directionally. So from the left, from the right, and our big limit, our two-sided limit. And we're going to do with a piecewise function. So the interesting part of the piecewise function is the break in the function. So as I'm looking at the piecewise function we have here, we have x plus 1 is what our function is doing when x is less than 2. Between 2 and 4, our function is this little parabola, and greater than or equal to 4, our function is this square root. 17, 18, 19, and 20 are all talking about what's going on at 2. So, for what's going on at 2, we are going to be looking at these two pieces of the piecewise function that surround the break at 2. So where x is less than 2 and where x is greater than 2. So we're going to use that right there. It tells us that's where we need to look. This limit with a little plus, this is the limit from the right. So that is where x is greater than 2. So the game here, the thing you need to pay attention to here is which function you're looking at, which piece of the function you're looking at. For from the right, we're going to use this guy. Because this is what is happening where x is greater than 2. So what I'm going to do is I'm going to take x squared minus 2. That's our f of x in this situation. And I'm going to do the limit as x approaches 2 from the right of x squared minus 2. And at this point, this is just plug the number in and go. So I'm going to plug in 2. So I'm going to have 2 squared minus 2. That's 4 minus 2. 4 minus 2 is 2. Now, from the left, since this is at a break in our function, from the left, we're going to look at this side. From the left is where x is smaller than 2. And of course, the other number here that we could be looking at is 4, and then we would use the bottom two equations. But here we're looking at 2. So our f of x was this whole thing, but if we're evaluating 2 from the left, then we're going to use x plus 1. And again, the math is easy. 2 plus 1 is 3. All right, now the two-sided limit only exists if those two match. So since the limit from the right was 2 and the limit from the left was 3, they don't match, so the two-sided limit does not exist. So this is what we call a jump discontinuity, because between these two, so from the left it's going to 3, so you can think of it kind of like this. If we're thinking about what a graph would look like, this is at 2. From the left, our graph is going to 3. From the right, our graph is going to 2. Not drawn to scale. And so there is a gap there. All right, last one, f up 2. So we actually need to, this is asking us to actually evaluate the function at 2. So we're looking for what is y when x is equal to 2. And here's the thing, this is less than, this is greater than, we have no value at x equals 2. There is no value, it's a whole. So this does not exist. So you just have to be careful and make sure you're choosing the correct line here from your piecewise equation to evaluate each limit that you're asked for. So hopefully those are helpful. Hopefully 17, 18, and 19 are very similar to a lot of the other problems you've got going on. Again, let me know if there's something that you need help with.